Okay, so Nathan Orr wrote this helpful pool heater service manual, okay? So just, you can print this out if you want. It's fine, it's only a few pages. It's actually something that you can read in like 20 minutes. Just read through and then make a mental note of the different topics. So when you run into something like that on a call, you know you can, oh, that's in that service manual. And so when you're doing service or install, there's some things in here that could both be helpful for that. Keep this source. It helped me a lot when I was going through pool heaters. I would just simply scroll through, and I was trying to figure out maybe a specific thing. We got limit switches here. I was trying to figure out something with the limit switches. High limit switches, it talks about them, how you're going to find them failed, and how to diagnose them, and what type of heater they're on. And there's even pictures. So props to Nathan for writing that. Everybody make sure you use that. At least read through it so you know what's in there. And then if I get a call about something that's really specifically on here, then I will yell at you about that, okay? All right, so heat pump pool heaters. Here is a nice, beautiful diagram of the refrigerant circuit. So is there anybody that doesn't understand the refrigerant circuit of the pool heater in here, heat pump pool heater? Great, we'll go really quick on this then. That's, well, I figured, because I mean, it's very, very similar to an AC. So you got all your components that you would with the AC. Where is the condenser? Wrong. Nope. The condenser. What is the function of the condenser in a refrigerant circuit? It rejects heat, condenses what? Refrigerant. Yep, it is on the left. So on a pool heater, we're using water to condense our refrigerant. So our outdoor condenser fan is on top of our evaporator, which is the coils outside. And so basically you're an AC heat pump running in heat mode is your pool heater. And so inside your pool heater, you're gonna have a heat exchanger that has water coming in, water going out, and both two copper lines going in. So what happens here is that from our compressor, gas comes in, superheated, cool gas, low pressure, gets smashed, it's really hot, goes into the heat exchanger, and then it transfers the heat into the water. And then it comes out as cooled liquid refrigerant and comes into our TXV. So we are gonna have pretty much every time, very rarely are you gonna see a piston, you're gonna have a TXV on your pool heaters. Pool heater TXV replacement is one of your most common projects on there, and they can be tricky. They're like a lot larger, and the connection points are really close to the TXV. You got to keep it safe. But if you're ever quoting a project with refrigerant on your pool heaters, just a side note, your liquid line dryer is a 1/2 inch. It's not 3/8, not your typical liquid line size. The liquid line is larger, it's a 1/2 inch. So when whoever is ordering or doing the project needs to know, like you tell Tim or whoever you're having ordering parts, also order a 1/2 inch liquid line dryer for this project, because we don't always have one just sitting at our shop. They're kind of an odd size. So just keep that in mind. That's off topic, but keep that in mind. Let's see, this is a heat exchanger. So every pool system, whether it's gas or refrigerant, will have some system like this. And that's what you see here doing the condensing job, right? So some system where you can see you have a water hookup coming in, water hookup going out, and your refrigerant lines, which in here they just circle through the middle of that water pipe, as you can see on here. So this is another common style. This is a heat exchanger. And so this is basically the only element that's going to be different than your typical AC system. This is your outdoor unit function on an AC system, the condenser. And then all the other components in there electrically are going to be pretty much the same. Some issues, common problems with heat exchangers. You can have them crack where they will actually leak water. So that usually means something pretty severe happened to the heater. Like you had a high temperature situations, your safeties weren't working properly, some sort of water flow issue, and you got up to a really high pressure inside the heat exchanger and it actually cracked the copper, and in that blowout scenario you knocked a hole somewhere in your heat exchanger. They are pretty tough. That is a rare problem. But if you come up to a system and you go to hook up your gauges and water starts spilling out of the lines, the only way water could have gotten into the copper is inside of this guy. You have your copper lines going in, so you immediately know you have a heat exchanger that has blown out, a copper line has blown out inside the heat exchanger and it's got to be replaced. So, I mean, unless you have a pretty new heater that is likely under warranty, heat exchanger is a pretty extensive project. You got more work than a compressor. So you have two lines like you would on a compressor, but you also have water lines. And then to get it in and out, you have to take apart that whole heater. Sometimes you have to move a compressor to try to get the project done. So you're doing a compressor and a heat exchanger. So the labor just suddenly becomes a lot, maybe more than replacing the whole pool heater, or close enough that at least you have that conversation where it's like, we can do this, but you know, you're almost paying the price of a whole new heater. Not a good option for you here. And for property managers, you're gonna run into a lot of older heaters. If it's a heat exchanger blowout, we just quote a heater. We don't wanna be trying to do a really expensive project for a property manager that can't see how poorly, how his heater is in such poor condition, and he shouldn't be making that decision anyway. You don't always have to give that option. Use your judgment on that. But when you do have a newer heater, I've done several of these for AquaCal. The other thing that can happen with heat exchangers is they will sometimes have the temperature probes go straight into there, or the water pressure hookup come out of there. And both of those have ports in areas that are more sensitive to water cracking. So you get a call out that my pool heater is leaking water. Oftentimes, where's that leak gonna be found on your heater? Anybody?
Close connection.
Yep. What?
Yeah, water sensors.
Yeah,
connection.
your water pressure switches connection points. And sometimes that's right in the heat exchanger, and you can have an easy repair. And sometimes the heat exchanger has cracked in that area because that's a weak point. That's a point that it actually goes into the water system. Anytime a heat exchanger is cracked, you need to think about this happened for a reason. Something's wrong here. Something's wrong with my water flow. Something's wrong with my safeties, not turning off my heater. Maybe my water pressure switch has failed, so my heater keeps trying to run at night after the pump shuts off. I'm gonna quote a heat exchanger, but I'm gonna put in the notes, and I'm gonna have the conversation with the customer that after we put this new element in, we can test this, and likely there's something that caused this failure that we're gonna run into that we need to diagnose. So you've prepared the customer, and also the returning technician doesn't just replace a part and not pay attention to what might have caused that. Like testing when they shut off the pump, does the heater actually shut off? Replace the part, leave the customer with the same problem, eventually the new part's gonna have the same issue. Some other elements that you have on your pool heater are your thermostats, thermostat probes, water temperature, and your pressure switch. I just have a little kit in my van that I carry the extra parts for my pool heaters. Here's a water pressure switch. So you're gonna see some version of this on your pool heater. Every pool heater has one, and it's just wire in, wire out like a float switch. And so the design function is that if 24 volts comes in and 24 volts comes back out, the heater's gonna know that it's okay to run. And so what will happen is if you have enough water pressure, it'll push up into here and actually close the connection between here and here. And it's that simple. And then anytime the pump runs, there should be enough pressure to close that connection. Your heater should be able to run. If not, your heater is going to say something like LO if it's a gas heater, or maybe flow, FLO, like for water flow, we got a flow issue. Or it could be one of the older style heaters that have the rheostats. So there's no digital display anywhere on that. And they have the float switch, pressure switches, all tied usually into the same circuit, and it just kills power. So you just go through and you're ohming out pressure switch, water pressure switch, and you're trying to figure out where do I have an open circuit on that style. But that's all it does. It just opens a circuit somewhere.
Wouldn't you have an open though if you're testing it with the flow off on that?
So you wouldn't test it with the flow off. You could test it with the power off.
Right.
So you can ohm it out with the power off, but you would want to test your water pressure switch by turning your pump on, making sure your pump's actually running.
Pump on the
Yeah. Yeah. So the other thing that can set off the water pressure switch is a clogged filter. Your pool heater should always be installed after the filter. So if the filter is clogged, or if anything's going through the water, it's been caught by the filter before it goes through your pool heater. But it should always be installed after the filter. So in that situation, filter gets clogged, now the pressure coming out of the filter is really low, and your pool heater is going to be going off on low flow. That's usually a pretty extreme filter issue. A lot of times, what will happen is you actually have a high pressure error before a low flow when you have a clogged filter. And why would you have high pressure, like a high pressure error code, refrigerant error code, if you have a clogged filter?
Not enough water.
Yep, and what's the connection there?
Water cools the refrigerant.
Yeah, water cools the refrigerant. So you don't have that good water flow, you're gonna go up on high pressure. You do find that you're gonna be replacing low pressure, high pressure switches more commonly on pool heaters than I would say on ACs, because there are just a lot more situations where they're going out on their pressure switches. So those pressure switches are being used a lot more often. Anytime you actually show up and your issue is a failed pressure switch, like a failed high pressure switch, again, stop and realize I can't just replace this switch or quote this switch until I find out what was causing that switch to open so many times that eventually it just stayed open. And that'll be the situation. Quick note on that, when you're doing a pressure switch, I have a couple in here. This one says it opens at 600 PSI, and then once the pressure comes down to around 475, so they're listed right on here, it'll close. What type of refrigerant would that be for?
410.
410, yep. And then I have another one over here that actually opens at 425, and then it'll close again at 325. So that would be R22. You don't put the R22 on the 410A system. They're both labeled high pressure switch. But whenever you're installing a switch, especially if it's a truck stock, look at the labels, make sure, and then this is a low pressure switch, make sure that you're actually reading those pressures, because you install R22 switch and it opens at 4 something, there's going to be situations where they're going to be running the spa. That water temperature is going to be 102 coming into that pool heater. That pool heater is trying to get rid of heat into 102 degree water. You're going to have really high pressure. Couple notes on high and low pressure issues. Because the water temperature changes so dramatically from maybe 60 degree pool to 102 spa, you're going to see a huge range in pressures. Don't just jump to adding refrigerant to pool heaters. Pool heaters can be pretty sensitive in charge. It's just a little bit smaller of a refrigerant circuit a lot of times, not all pool heaters, but some of them are smaller. And so you find really high pressure, try to figure out why. Is my pool hot? And is my incoming water hot? And is it pretty hot outside? That's why I have a really high pressure. Do I have 400 PSI on my discharge line, but my pool temperature is 72? Then I'm probably overcharged. Now I need to quote the customer to remove the refrigerant and weigh it back in. So we actually have the correct amount of charge for this pool heater. And so, same situation, you're gonna run into a lot of extreme temperatures where your water temperature is really low, outdoor temperature is really low. You're gonna have very low pressures. You can't just show up and start adding refrigerant. Get familiar with the concept that low water temperature, low outdoor temperature, you're gonna see really extreme low pressure. And that's why they all have some sort of defrost mechanism in them. So a heater is gonna have typically 2 thermostats, one for water, one for defrost, connected to the board. And it's gonna have, on the defrost, the only function is it shuts your fan off. Shuts your compressor off and just leaves the fan on. So, you know, like on a heat pump system, it'll actually reverse the refrigerant, so you got hot gas flowing through the coils and you can melt your ice real quickly. But if it's 45 degrees outside, you're trying to run a heat pump, already your saturation's gonna be below freezing, so as soon as it starts running, it's gonna start freezing. Once the ice builds up to a certain point, your defrost sensor is gonna go off, your compressor shuts out, your fan just keeps spinning. But it's 45 degrees outside, that ice doesn't melt super fast. It's gonna be in defrost for a really long time. That ice melts, system comes back on, immediately starts freezing again. And that's why a lot of times you're gonna have to be able to tell customers, under 50 degrees, this thing's almost useless. And that's just a realistic fact. If your pool is already warm, it has a heat blanket across it to hold in the heat, and it's 50 degrees outside, yeah, you're probably gonna be able to switch over into spa and slowly heat up your spa. But you're not gonna be able to change the pool temperature that much in that kind of situation. So you'll run into that, and just be aware of that, be able to tell customers that. Even in installing, you guys are gonna find that you're putting a new heater, you call the customer, new heater's in, okay, turn it on, guests are coming in tomorrow, we need that pool heated. And it's like, well, it's 42 degrees right now, and I'll turn this heater on, it'll run for like 4 hours until your pump timer shuts off. And then in the morning, that'll come back on, but it's probably gonna be 2 days before your pool gets warm, like this kind of weather. They need to know, they just got a brand new heater, set the expectation straight. Just because it's brand new doesn't mean that it's gonna heat really fast as a heat pump on a cold day. So, and I think I mentioned before, but this is what I use for testing the water temperature difference. So if you're gonna check your split, it's a water split. We're trying to change the temperature of the water. So you have, I just use this right here. It comes with your meters. Plug it into here and drop it in the water in the pool. And you know from swimming in a pool that the water on the bottom of that pool is a lot colder than on the surface. Try to get it as deep as you can. And then you're probably about two degrees off from the very base where some of your water is going to be drawing. Your pool pulls in water from the base. And then you take your other piece and you can just stick it straight into a jet somewhere when the pool heater is running. So if the pool heater is running, you should see a 3 degree difference typically. Depending upon weather outside, it could be like 3 to 7 degree difference. If you have great weather outside and it's picking up a lot of heat and your pool's colder, you're gonna see more of a extreme difference, temperature split. So, but if you're getting a 3 degree difference, you can have full confidence that your heater is doing its job. Even if it looks low on refrigerant because it's a colder day or whatever, you can have confidence to tell the customer that. And a lot of customers are just like, 3 degrees, are you kidding me? That's all it'll do? Yeah, that's design. Like, that's all it'll do. The only other thing I was gonna say is check your pump timers. When customers are having problems heating up the pool, they might have a timer that's only on for a few hours in the day. And so you can talk to them about it. We can run your pool pump timer longer, and then you can actually heat. So get your supplies. If you're a service truck for servicing pool heaters, make sure you have your pressure switches, your flow switch, your temperature sensor, your saddleback.
Thanks for watching our video. If you enjoyed it and got something out of it, if you wouldn't mind hitting the thumbs up button to like the video, subscribe to the channel, and click the notifications bell to be notified when new videos come out. HVAC School is far more than a YouTube channel. You can find out more by going to hvacrschool.com, which is our website and hub for all of our content, including tech tips, videos, podcasts, and so much more. You can also subscribe to the podcast on any podcast app of your choosing. You can also join our Facebook group if you want to weigh in on the conversation yourself. Thanks again for watching.